welcome to Project of the Month, everyone. Thank you for joining us this morning or this afternoon, depending on where you are. I'm Zach Semke, I'm director of the Passive House Accelerator, and we are very excited about the presentation we have today about scaling passive homes with microfactories. And the Passive House Accelerator is where we explore how to slash the greenhouse gas emissions from our buildings and make them more resilient to the impacts of climate change. And this is a great exemplar of both of those things. So it's going to be really, really excellent. Today, our hosts are Beverly Craig of Mass CEC and Kim Davis of Passive House Accelerator. So with that, I'll pass it off to you, Bev.
Welcome, everybody. I was just saying right before the hour that I'm so excited to have a good news story because we all need that right now. This project that we're showcasing today, I have had the honor of actually going on a tour of. It was fantastic from the inside. I was so impressed with a 2-bedroom, 1-bath accessory dwelling unit, how livable and how maximized the space was from the inside. And people often complain about Passive House not having enough windows. Not with this one. It's beautiful and I really enjoyed it. So this is an example of modular, of Phius-certified, of an attention to low embodied carbon, all electric, solar and storage. And we're talking about modular offsite construction to try and make this all easier and over time to bring down costs. This was done on an affordable housing budget. So you're going to find this a really exciting presentation. I'm going to quickly introduce our speakers today. I guess Ankur Podder leads the decarbonization and design integration at Reframe Systems. He's an MIT-trained architect specializing in embodied carbon and digital design fabrication. And in 2023, he was awarded the ENR Top 20 Under 40 Young Professionals National Award in the AEC industry. Before joining Reframe, Ankur worked at Department of Energy's National Renewable Energy Laboratory on high-performance modular construction, which is what we're going to be talking about today, and also improving solar+storage integration. He was born and raised in islands off the coast of India, where he experienced how very important self-reliance and resilience are in the face of climate change. So let's get started on our presentation. Welcome.
All right. Thank you, Beverly. Thank you, Kim. Just FYI, we also have Jessica Boatwright joining as a co-speaker with me from Reframe. While I'm pulling this up, Jessica, do you want to say a quick hi?
Sure. Hi, everybody. Jessica Boatwright. I had business development and strategy at Reframe Systems. I am Boston-based and have worked in public finance and real estate development for many years before joining Reframe in January.
Thanks, Jessica. All right, so let's get into it. We are Reframe Systems. We are here based in Massachusetts. I am currently calling from our factory in Andover, just north of Boston. We have our microfactory number 1 here, and we're going to talk scaling passive homes with microfactories. So yeah, about Reframe Systems, our founding team is from Amazon Robotics. They spent combined like 10 to 20 years deploying efficiency across fulfillment centers in fulfillment centers across Amazon warehouses. And now they are taking up a challenge of how we can bring efficiencies into the construction industry. We started back in late 2022, a little more than 2 years old now. I was one of the earliest employees joining from the AEC side, joining the founding team. And we are actively delivering homes to paying customers right now. The first 6 months, before we had a factory, we were based out of Greentown Labs, good old days, just a couple of desks. And yeah, Beverly, I see, definitely a shout out to just the excitement in Greentown Labs, right, where you can talk to multiple passive house experts and like SWA was there, and stumble upon new products that are up and coming in the building technology niche. And we soon realized that we as Reframe can think of us as a platform integrator where we can actively work with a multitude of products which are up and coming and also matured, and think of our home where all of these products come together, right? And then we are what would bring the homes to scale, and therefore everyone else can grow with us. And so as of today, we are 25 full-time people, again, located here in Andover. Today's showcase is about our first home, our first project, and we are really proud of it. We endearingly call the first project as Dorothy, coming from the Dorothy Road that's right in front of the site. But we are Phius Zero Design certified as of today, and this is hot off the press. Hers -25 for the asphalt her store. With solar storage, very low carbon materials, and we're gonna dig into it further. But this is an affordable rental unit. It's an ADU. Our client was Housing Corporation of Arlington, HCA. If Erica Schwartz from HCA has joined or not, but if you are here, Erica, I'd love to hear you say hi. But you guys really gave us the opportunity to bring our first home out of the door. And the first home being passive house as well, let alone the first home. So it was definitely complex, a huge learning curve for us, and we'll dig into that. But we made sure that we stay true to our mission and really focus on the prefabrication approach in our factory to get this project out of the door, and excited to share the learnings with you all. And so we went from start of construction to finish in 48 days for our first house out of the door from the Andover Microfactory. The site was in Arlington in Massachusetts. For those who are local, might be familiar with the area. This you can see as our as-built photo. Some key highlights here. We did our blower door test on site, and we're 20% more air tightness than what the passive house levels of 0.6 requires. At some point we were, at that point you can't even tell in the regular scale how low it is. And so it was, we did our own analysis to get to the Hurst rater helped us get to the 0.47. It was not obvious to us what the right number is initially, because the number was so low. We got the project out of the door in 48 days. And when I say out of the door, this is 48 days to completion in the site, and which is 2.5x faster versus the traditional approach. Our team on the build side is made up of 60% very new and apprentice builders rather than master builders and master carpenters. And that is also our approach to find more younger workforce in construction industry, and act as a conduit for them to enter the construction industry. But also their first project has been a passive house project, right? And so for them, that's the baseline. And so it's really amazing to see how they went through the learning curve, and their skill sets are now to deliver a passive house, right? And so that was really amazing to see, and we'll continue on that path. 50% less carbon, and we'll talk more about that and how we were able to achieve that versus baseline. So construction of Dorothy, something here, digging into it. Again, first project that was built, the magic behind our building platform is laid out here. It's essentially integrating vertically the design and construction steps together. We are taking every task from the initial design stage to all the way to the certificate occupancy under one roof, right? And that's the delivery model of Reframe Systems. Our entire construction process is software driven, and this would be very interesting to all the architects here on listening. We go from the architectural drawings through engineering down all the way to the detailed work instructions for every process. And that's what the software is powering in our factory. And then the final steps are performed at the factory by either the robot or the person. And we are currently going through the process of where to stop the work of the robot and from where the human operator's work begins. And this provides us the digital version, the concept, the pixels to pass that you can see here, provides us a single source of truth that allows us to go from low-skilled workers, apprentice level, to train them to go all the way to a completed project, because we are taking all of the complexity and moving it into the software, having a very high fidelity 3D model available to build off from. Next slide would be where we watch a video. There's no audio, so don't worry about it. But just showing this entire idea that I was talking about, where we live in the digital world initially, and the information then flows downstream, where you can see the robot here picking up the studs, framing the wall, nailing, and then you have the ready wall then sheathed by the robot as well. And then the wall with sheathing comes to the human operator, who then works on that wall using digital screens and using the parts to install MEP that you can see here. That was our plumbing wall. And this is the time lapse of Dorothy being built in our Andover microfactory. And we built the two boxes separately, built them, shipped them on sites, set them on site on top of each other, and did the final work. And all of this happened in a span of 48 days. So moving to the next slide, just some shots from the factory itself. As you can see, we built the wall panel first, and that allows us to maximize work at that panel level. And then the box actually comes together at the later stage of the construction, where the box comes together and minimal work happens in terms of like continuous insulation and some amount of cladding that goes in per module, and then we ship the boxes to the site. And so the two-story project here, we went through some quick site improvements to get the site ready. The site is at the backyard of an existing building. The existing building, the entire site also belongs to Housing Corporation of Arlington. And we used the backyard and turned it into a small little, hopefully beautiful looking front yard. And then the front of the ADU itself, it has a really dense tree cover, and it's beautiful to look outside through the large operable windows that Beverly was talking about earlier. And the project doesn't really end without the celebration. It was our first project, and so we are really proud of it. We had an entire ribbon cutting ceremony with HCA. A lot of folks came down to celebrate with us. I think this would be a good time to watch a video. Okay, let's do it.
This home represents progress and a brighter future for our entire Commonwealth. It embodies our shared values of inclusivity, sustainability, and innovation. We celebrate today for the positive impact that this ADU, this home, will have for every family who lives in it in the future.
Well, we think it was really inspiring. I was absolutely blown away with the turnout that day, and hopefully that came through this video. But again, we had a few open houses for those who were able to come down to Arlington and take a look at the house. The lottery went through for the rental unit, and Jessica can speak to it if the home is still accessible. But for those who missed out on it, we have some really nice photos from the inside. I'll just like breeze through some of these photos, but talk about things that we want to care about, which is, we have built-in cabinets in the bedroom. We have the finish that you can see on the floor is a cork finish. So that also benefits us from a carbon perspective. So we have cork finish floor throughout. Our entire staircase subassembly was built out of Baltic birch. That's a 3/4 inch Baltic birch plywood. So and then really shout out to the build team with such a really good finish and workmanship when it came to the stair module itself. We also have this, the kitchen right here that you can see. It's an all-electric kitchen with induction. And we have a span electrical panel sitting inside. It's somebody, our electrical installer was talking about how it's the Lamborghini of all electrical panels, and it was definitely a little complex, but it takes a lot of complexity out of the solar plus storage system and makes it super easy for the occupant to understand how the solar system works with the rest of the electrical infrastructure. So going to just switching gears a little bit to diving deeper into the building performance itself. And since this is the Passive House Accelerator, I think these would be very interesting for everyone to know about. We have some key strategies that I want to talk about in terms of our high performance design, because we are all electric with continuous insulation, triple pane windows, and solar plus storage. I talked about the span panel. We have a ducted heat pump system, which is located under the stair module. So you can't really see or tell where it's coming from, but it's super quiet. And we were able to do a design integration such that we don't have it sticking out like a sore thumb. We have the end-phase battery, which is connected to our 16-panel solar system, and it's the battery is exterior mounted on the back of the ADU. Of course, going by the requirements, we have an ERV with MERV 13 filters, and the ERV is not a standalone ERV. We have the ERV integrated to the supply side of the heat pump. And heat pump water heater sitting inside the house behind the bathroom with access through sliding doors in there. And again, talking about our passive house windows with a very typical Buck installed systems. We worked with Yarrow, who are based in Cambridge, and the windows are actually coming from Poland. But Yarrow was the local supplier for us, and they were really kind enough to come to our factory and teach us the various aspects of flashing the windows and getting the windows correct in order to meet our air tightness requirements and our continuous primary air barrier goals. And then you can see an aerial view of the solar panel. Enhanced air tightness, we are really proud of it, especially working with our first-time builders, with 60% apprentice builders who have never even heard of passive house before we got in on the floor. Got an ACH50 of 0.46, much lower than the 0.6 target that we had. And this is coming from the side blower door test. Key contributing factors, I would say, definitely, working in a controlled environment itself gives you a lot of control on the primary air barrier install and the taping, completing all the through wall penetrations with gaskets and flashing all happening in the factory. And then adding the cladding on top just seals the entire module at that module level. Of course, as we get to scale between multiple modules, we'll have to pre-plan the patchwork, whether it's through prefabricated panels, which has the entire build-up starting from the insulation outwards, ready and prefabricated, so that there's quick install post module primary air barrier taping is something that we are looking into currently, just so we can maintain the continuity on site as well, which we tried at scale, at a certain scale in 2 module this time. And as we scale up going to triple decker and multifamily, that will be really key to be able to maintain this air tightness goal that we have already challenged ourselves with. On the low carbon side, I think it's fair to kind of talk about a few key strategies. So for everybody here, passive house, you can, as of today, you can meet passive house without really caring much about low carbon, right? And so you can have your continuous insulation with rigid foam, but we put a stake in the ground and say that we are not going to use rigid foam for our continuous insulation, and instead we go with biogenic carbon material, which is the wood fiber continuous insulation. So that gives us a lot of sequestration benefits, but also gets the foam out of the system. And similarly, we looked into the cavity insulation. Like, so can we switch mineral wool to something better and something more, something which is lower carbon? And we went to recycled cellulose, and it's basically a dense packed recycled cellulose in the cavity. But these are different tweaks that we applied to throughout the building system, especially in our envelope. But the thing that we are that really moved the needle for us with this project and brought a step change in our carbon mission was getting rid of all the concrete foundation and instead going with helical pile foundation, which led to 8.5-inch crawl space from the finished grade, but that allowed us to prepare the floor cassette in the factory and then have very minimal work that happened on the site, where the piles were welded in place as the module was set on the piles. The piles was prepped in the site, and but then gave us a step change in moving the needle when it came to carbon. For passive house, one of the things that I have noticed in the past, in my previous job as well, where people who are the occupants, they feel like it's might be a more complex experience, or there are a lot more systems, right, that you are packing into a passive house. And so as Reframe, we definitely care about the occupant's experience. And so with our every house, we're going to provide an information book that talks about what are the kind of filter changes that you need to do across like the 3 subsystems that you have for heating, cooling, and hot water. And then also any kind of like alarms and different kind of maintenance that you need to care about. And we handed this not just to the occupants, but also to HCA, as their facility management team can be well versed with how a passive house could be a little different to maintain versus a typical home. As of today, we are, again, Phius-0 design certified and going through our final certification steps with our final host rating, which I talked about earlier, which is in the -25. And we want to bake this into our building system and carry this forward across different typologies. We have Jessica here who would I'll switch to Jessica here, who can talk about financing and then talk about a little bit about our pipeline and our products. So that everybody here can understand that now that we have proven our model and our building system at a smaller scale, what is our approach in terms of scaling this building system up across triple deckers and duplexes and small to medium multifamily, and how does that pipeline looks for us? So Jessica, do you want to jump in?
Yeah. Hi, everybody. So before I jump into sort of what our future looks like, just I know there's been some questions. I've been trying to monitor the chat, and I think I'll get some of them in here and then some of them after. So first, just on project financing, this ADU was built at a cost to the Housing Corporation of Arlington of $275,000, which is $275,000 for a 2-bedroom, 1.5 bath home. We're actually exploring it as a cottage home or a townhome with some other developers. So it's a pretty significant size dwelling unit. There was a small discount for early adoption. Our target price for design build is about $275 a square foot. But just wanted to recognize that this project in particular was primarily funded by the Arlington Affordable Housing Trust Fund. I did see Sarah Suarez from the town of Arlington in the call, and they have just been such phenomenal partners to us and especially to the Housing Corporation of Arlington. So wanted to call them out and call her out and just say, you know, one thing that is particularly advantageous about the opportunity to do more info with zoning reform is that we can have projects like this where the Housing Corporation of Arlington already owned the property. They had a 2-family development that was operating there. They were able to, because of the zoning reform in Arlington, they were able to build an ADU there. And because it's a relatively small project, they're able to fund it just with municipal funds and some proceeds from some work they're doing in their own portfolio. This is actually the same model that the Somerville Community Corporation is using for our next project. So it's a really nice way for developers like community development corporations to keep their pipeline full and keep incrementally adding housing in addition to the longer timeline, larger tax credit projects. And then we're going to move on and just talk briefly. I know we want lots of time for questions, so I will attempt to be brief to talk about what's next for us. So our portfolio is a missing middle small multifamily portfolio. That means that we have a project size range from a single family that can be used as an ADU. We also have a larger single family can translate into a townhome, as well as a triple decker product and a medium multifamily sort of garden style apartment building. While we're developing all of those, we are also laser focused in the factory on developing the components that we need to support a building system that's optimized to design for manufacturing. And we can get into it more in the Q&A, but our manufacturing platform is the connecting thread is really software. We're using a combination of robotics and human labor augmentation. So we can talk about that, but I know there were some questions about kind of who does what. So then just quickly, this is our product pipeline and what we have in development right now. We're contracted for 2 triple deckers in Somerville with 2 different clients, a CDC and a private client. We are working on a couple of duplex communities mostly with private developers, but also one with mass development, and then a small multifamily as well. If you go to the next slide, these are just some product samples. You saw some interiors of our ADU, and then this is a rendering of a duplex community that we're working on in Devens, Massachusetts. The next slide is a rendering of the triple decker product that we are working on in Somerville. And I know there was a question about AMI levels. So the Arlington ADU is being rented at a 60% area median income rent, and the Somerville Housing Trust really pushed Somerville to make their triple decker an all 50% AMI rental unit property. So we're excited that it is more targeted at a lower area median income. And then just 2 things we're working on. One, we're really excited to be in Mass CEC's Innovate Mass Grant Round 2 for looking at how to do solar roof cassettes that are installed in the factory and doing some prototyping work. And then the final application that we have begun talking to some 2026, 2027 projects about is that our manufacturing line really focuses a lot of our attention in what happens to the panels themselves, which means that we're well set up to create an exterior envelope product for retrofits. And that's such a huge portion of the market that we need to address to look at decarbonization. So we're enthusiastic about that. Before we round up the talk at you part of this, I also did want to call out, I saw Monica Gregoire from Andover, which is our hometown, is also here. And I see a lot of other friends, but I feel like those city officials are so essential to moving housing and to businesses like ours being successful. So I just wanted to thank our friends at the municipalities. And the last slide has, just wanted to call attention to the last slide that Kim put a link in the chat because we are starting a round of monthly tours on the 2nd Wednesday of every month. They actually start next Wednesday at 2:30 in the afternoon, and there's a link in the chat if anyone wants to come and visit our production line. And we're happy to take any questions.
Great. I think Kim's going to be dropping questions in the chat, but I wanted to, I already asked in the chat for the first 2 people. Diana, Dina, do you want to unmute and ask your question?
Yeah, I was just curious about the most tricky parts that are usually the passive house elements, most difficult to do on site, which is air tightness, installation of windows. Is that something that was done by the prefab robots in the first part, or is that something that the apprentices were doing afterwards in the factory? What was the sequence of work and who was in charge of what? Thank you.
Yeah, no, great question. Yes, so for Dorothy, we drew the line where once the wall was framed and nailed, everything and sheeted, everything else from after that was taken up by the human operators, by our build team. Yes, the passive house details and all of that work was done by our build team, especially the apprentice team. And one thing, while I'm talking about that, it was it went much faster and much more accurately when we had visuals of our documentation as work instructions, right? And so like somebody who is doing the flashing at the taping at the for the first time, of course, like we ran our own training and prototyping exercises, but once we had the 3D digital model with all the layers and broken down in what is the order of operations, it went much faster. And honestly, like do it a couple of times and then just like repeat it, right, at scale. And so that was how it went.
Thank you so much for this presentation, Ankur and Jessica. Before we get into the full question and answer, we're going to have a quick sponsor break, and then we will be in the order of the questions that are here. Thank you, guys.
Yeah, thank you very much. So I just want to take a moment to thank the fine organizations that make our work possible here at Passive House Accelerator. So starting with our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you too to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwool North America, and Zola Windows. And thanks too to our champion sponsors, Bewizo, Icon Windows and Doors, Intelligent Membranes, and Source 2050. And thank you to our patron sponsors, Brennan, Holstrom System, Innotech Windows and Doors, Lamelux, Longboard, RDH Building Science, and Sanderson Sustainable Design. Thank you, sponsors.
Great, thank you, Zach. I'm going to be helping Bev out today. Sean is not here today, so I have some pretty big shoes to fill, but we'll see how we do. Starting off for the Q&A, it looks like we have Justin Taylor. Justin, would you like to ask your question?
Yes, thank you. That was a great presentation. Thank you. You can all hear me? All right, cool. I was curious to know about are the finishes, how much of the finishes are applied on site versus what is applied in the factory, especially like exterior finishes and also doing interior finishing?
Yeah, we completed all of our interior finishing per floor or per module in the factory. So with our entire drywall finish, it was all done in the factory. Now, when the two boxes came together, there was final finishes to be done when the staircase module came in, right? With the staircase and building the staircase in place, there was some patchwork to be done. That was the interior. For the exterior, as you saw in some of the images, per module, we had the cladding in, but we had hold-offs from the top in order for us to access the zip sheathing. Since the zip sheathing was the primary air barrier between the two modules as well, we had patchwork to be done on site to tape the zip, then add the continuous insulation, and then have the patchwork of the cladding done. But so in that case, like percentage-wise, yeah, 80 to 90% of all the exterior was done in the factory, and we shipped to the site with the exterior per module in, and we filled in the patchwork between the two modules on site.
Great, thank you. Justin, did you have any follow-ups or did that answer your question?
No, that was excellent. How much time did it take on site when you were to actually did that last bit of piece?
For the first time, it went longer than we wanted it to go. No, definitely. I mean, it took a week, an entire week, for that to happen. Looking back, we think we could have done it in a day or two if we prefabricate that, which I was talking about, basically treat it as an exterior insulated panel system, the patchwork itself, prefabricate that, and then just like lock it in, right? Like after the taping has been done.
Thank you.
Great, thank you. It looks like Bev, you had a question in chat. I'm sure you've come up with a few more since that was the beginning of the presentation, but do you have
Well, it
anything
already
to
got
ask?
answered, which was so I'll pass to the next person.
Okay, perfect. It looks like Zach Gordon, you're next.
Yeah, so let me turn my camera on. So I think this was I caught it for Somerville, the affordability piece, and I know the initial unit in HCA was also affordable, and I may have just blanked out and missed the response, but curious how the affordability works for that initial unit. If is there like a subsidy attached to it, or is it just again like the Somerville one restricted to a certain percentage of FMR? So sorry if I missed it.
No, no problem. So both of those projects are funded by local housing trusts that are the ones that put the affordability restrictions in and that have provided the subsidies for it. And those are managed by the developers themselves. So we're really excited to have a product line in the affordable space. I've spent most of my career in the affordable space. It's really mission critical to me. We also do have developers that we're working with that are doing traditional market rate as well. And our sort of product goal is to ensure that we have a product that a developer could comfortably rent or sell at a middle income rate, with the idea that, you know, doing luxury upgrades are easy, and that standard of unit is also going to be very useful in the affordable space.
Sure. Thank you. Yeah, just for so I work for the Cambridge Housing Authority, and one of the things I've been working on is exploring ways where maybe we could work with single family homeowners in the city who have space for ADUs to, you know, then place like project-based vouchers in ADUs and kind of work out a deal where we cover some of the loan costs, something like that. So this has been really, really helpful and exciting. So thank you for all the information.
That's a brilliant idea too.
Thank
We're
you.
very excited about that.
Me too.
Great, thank you, Zach. Next up, we have W. Greg is the handle, and it looks like you had a couple questions, so maybe ask your best one to start.
Hi, it's William. Ankur answered the most recent one about climate zones, but I was curious, and I apologize if I missed it in your presentation, but wanted to hear about the roof system.
Yeah, we can talk about the roof system real quick. So for Dorothy, we have a very low marginally sloped roof. We were restricted by the height, and that pushed us to have a very low profile truss roof system. And so we explored SIP's roof as well, but it didn't work out for such a small project and it didn't make sense. But yeah, we have a truss roof with cavity insulation in it, and we do have and it's a TPO roof. So we have the TPO roof on top with one thing to note, since we're talking about roof, is we really pushed hard on our solar mounting system. So in our factory, we were able to install the mounting system for the PV. These were the L brackets that go down into the truss. And we did all of that with the TPO flashing around the mounting with the TPO boot in the factory. And we shipped a pre-mounting system done out of the factory. And all that was done on the site when it comes to solar was installing the PV panels itself.
Nice.
All righty. Next up, we have Michael. Looks like you're still on the call. Would you like to ask your question?
Hi, yes, thanks very much. I'm curious about how much of the total cost was involved at the site prep, you know, the water sewer connections, piers, and the rest of the groundwork.
Yeah, well, Jessica, you can speak from the cost side. In terms of the work itself, it was on the utility side, it was fairly simple because we already had an existing building, right? And so we had to pull the utilities from the existing building. One of the critical components of reducing the site work and the cost that was associated with the site was on the foundation side. Just two key strategies that I wanted to mention. Jessica, do you speak from the cost side?
Yeah, I don't have the budget memorized myself, but But I will say that one thing that I think really sets Reframe apart from a lot of traditional modular producers that people, particularly in the US, are used to working with is that we're a fully vertically integrated company. So we manage site work ourselves. It's our price goes from design to certificate of occupancy. So all the site work was performed by a local subcontractor that was a sub to us. So, I'm happy to get more information. This site, thankfully, was not a super complicated one. But we are trying to help manage that cost by being sure that the developer customer gets a single price and has a single point of contact.
If I can just jump in, I'll get more details because Andover's not too far away, and you're certainly going to see me at one of your tours. But also, we have a new producer coming into Holyoke called Sublime Systems, which has designed a alternative concrete that is stepping away from kilns. So we're working very hard so that we can make that the concrete base going forward.
Yeah, we discovered them at Greentown Labs. They were right there too, and we have been in touch. And yeah, Michael, would love to learn more and how we can use some of that material back. I mean, again, we're definitely putting a stake on the ground in high carbon concrete, but the concrete world is moving really fast, and as we have more better mixes, we'll be really curious to see how it affects our building system.
Great, thank you, Michael. I think this was answered in chat, but maybe there's a follow-up question. CSO USA is the handle. Are you still on the call? Okay, I guess we'll move on to the next one. We have Sean Rose.
Hi, great presentation, really relevant for me. I'm on the opposite side of the continent, north of the border from you. And my question for you is, can you share the estimated startup costs, capital cost for your microfactory?
Yeah. So another thing that for the second time when we come back and talk more about the manufacturing system is that our co-founders come from Amazon Robotics and have been really focused on using the knowledge that they learned about delivery to last mile facilities and being able to quickly mobilize in relationship to pipeline and demand. So we have a very small factory footprint. Our factories are between 25 and 50,000 square feet. And with really focusing on a targeted low capital investment and operating expenditure. So it's about $5 million to stand up a new factory. And our target is to be able to do that in 100 days, which means that that we could sign a contract for a sizable demand in a new market and set up a factory, in time for probably have the factory open before all the entitlement is done.
Appreciate that. Thank you.
Thank you, Sean. It looks like Dina, did you have another question? Would you like to come on and ask?
There were two questions kind of rolled out in one. I think one was answered already in the presentation. I wanted to know what was the feedback from the Housing Corporation or the local housing funding trust. Would they be keen to roll this out further? And the second part was if there are any limitations to this model in terms of complexity, but you already mentioned that there are different types of housing that you can tackle and have already in the pipeline. Perhaps more important would be then, what's the prep work? What's the time, the time from the start of the design when up to the moment when you can actually start on site to do the prefab? How much time it takes to introduce all the data into the kind of the robotics part of it. Thank you. And great presentation. Thank you so much.
Thanks. So I can't speak for the Housing Corporation of Arlington. I don't think Erica was able to join us, but we are really hopeful about doing additional work in Arlington. They've been we have a great relationship with them. Actually, next week I'm giving a talk with Erica about this project. So it continues to be a good relationship. And the lottery for the unit, which is administered by the state because it's an affordable unit, is actually happening tomorrow. So so we don't have anybody in there, but really, really excited to welcome a tenant into the unit. And certainly have had a lot of exciting conversations about how to expand this project into other places. So our general timeline for product delivery is about 9 months, but there's variation depending on product type. Next year, we should be in a place where we're producing about 50,000 square feet a year out of our current factory, which is actually an undersized factory. It's about 17,000 square feet. So, that's depending on the product size, that's about a week in the factory for something the size of an ADU. And then the other time is coming, in the upfront design work and permitting and entitlements. And then site work, we think, should be, between 1 and 2 weeks.
Thank you. Great, thank you so much. William, do you have a second question?
No, thank you. I think it was answered.
Perfect, great, thank you. Next we have Michael. If he's still here. Looks like he's off the call. The question was already answered, so I'm going to move to the next one. We have Steve. Are you still here? Would you like to come on and ask your question?
Hi. Yes, I know there are multiple Steves, so I'll go ahead and jump in. Greetings from Southern California. How is everybody today? Really exciting opportunities here for efficiencies, for a future of building. I was curious about the flexibility of the build platform. Ankur, I know you said that you've worked with third-party architects and you're interested in doing other designs, but I was wondering if you could kind of speak to the flexibility of the build platform to work with third-party designers, architects, and engineers.
Cool. Yeah, no, that's a great question. So if you go back to the slide that Jessica was presenting, if I can refresh that in our memories, we have a component first approach, right? And so in that case, you can think of our envelope system as a component and our roof system as a component, right? And then we basically have populated our build platform or the design platform in such a way that these components exist. And we have made a bet on software tool that we are using that allows us to actually have a living, breathing library of these components. So at that point, we are able to take any design and run it through our system, right, of the build platform, and then to get almost like a model checker at that point, that okay, is it 100% compatible or is it 80% compatible? And now, so there are two scenarios. One where it's 100% compatible, and we can basically add our layer of our building system or building components there, then we are good to go, right? The reason why we wanted to take that approach for a potential 100% compatibility in any design is that we are accepting the fact that if we standardize too much in our design, then a lot of sites out there, we kind of write ourselves out of it, right? We have to say more no's than yeses, and we don't want to live in that world. And so every site, we understand there are unique challenges, and therefore our build platform needs to be flexible. Then the other component that I really want to talk quickly is about our factory itself. Now, let's say the scenario 2 where it's 80% compatible, and now we really need to rethink our building platform to a certain extent to introduce some new features. Our microfactory then should be flexible enough in order to accommodate that change. And that's currently, I would say, come to our factory and we would love to take you around and show you how we are able to achieve that. And that's essentially where it's going to break and make or break this model of a flexible build platform, where the operator or the robot doesn't care about what the recipe of the build system is, as long as our software can provide the new recipe and the human operators or the robot can build out of it. And so that's the recipe first approach that we are taking.
No, that's killer. Thanks, Ankur.
Thank you, Steve.
Thank you.
It looks like next we have a question that that was answered in chat by Larry Link. I just want to see if you had any follow-up questions or comments.
Yeah, the question I had was about, robotic construction versus human assembly. And Ankur, you answered that, you said it's 20% robotic as of today, and it sounds like that's maybe going to go up as you sort of move forward. Is that right?
Correct. Yes. We have a dedicated robotics team, a growing robotics team in-house. We're actively working on moving more and more work into the automation, especially things that, as I mentioned candidly on the chat, like blown-in insulation. Nobody wants to do blown-in insulation and get dirty. And so like that is ripe for automation.
Yeah. So kind of a related question, but a little bit different was, I was interested to see that you guys are scaling up to kind of a medium multifamily product. I'm a property developer, and I'm interested in doing, sort of a medium multifamily type of product that's more, in the 20 to 30 unit range, kind of like a garden style apartment complex. And I'm curious to know if your platform or your plans for scaling this up is the prefabricated aspect of this meant to be similar to this ADU typology, where you have sort of boxes that are each unit in some way, and then the boxes are sort of shipped? Or is it more intended to be a panelized system where the panelized, and the various kind of components of the building are the prefabricated things, and then it's more of an on-site assembly? Like, I'm just curious what your thinking is as you're moving into kind of a medium multifamily product, and sort of what you see. I mean, personally, I see a lot of limitations as it relates to the individual boxes. I just went to an affordable project there was a tour that was put together by Passive House Accelerator, or was sponsored by Passive House Accelerator, for an affordable housing project that was in Brooklyn. And it's the classic sort of like box type construction of a senior housing project. It was a passive house project, but no matter every single one of these that I've been in, it still somehow feels a little I don't know, cookie cutter or something like that inside. Like, it just doesn't quite feel right. So anyway, I'm curious to hear your thoughts about box type construction versus more of a panelized approach.
Yeah, I would, and I can start answering, and Jessica, feel free to jump in, but I would take the verses out and say it's not either or, and that flexibility is what's going to, where we are going to win. And I'll tell you why. So we are a panelized first company who can also deliver boxes or panels, right? So our approach right now is where we build the panels and maximize work at that panel level. And if you visit our factory, you will see that we stay at the panel level right to the very end. And because we are a microfactory, we also cannot build a box and move the box around, right? And that's the pressure we have applied. So the box comes together right at the end. Now you could argue that, hey, here is a site where I don't want the box and I want you to just supply us the panels. We will do that, right? And so we want to keep that optionality of we can supply fully finished panels or a box, depending upon the site, depending upon the project. And we want to completely say, don't fight between panels and boxes. Both are necessary, and it depends on the site. And it's up to the design and the manufacturing system to be able to build in that optionality in-house. And so that's how I would put it.
Yeah, and two things
Jessica, do you want to add something?
Two things I would add. One, we are currently building volumetric boxes because we think that you can get the most precision if you're enclosing the walls in the factory, and particularly in the US, that's your choice, is right to do a volumetric if you want to do enclosed panels. The other thing is that, sorry, I wasn't sure if we were sharing the right thing. The other thing is that we are really excited about moving to a place that most US companies are not doing, which is to be delivering and designing in smaller and smaller boxes. So as an example, our triplex is going to be 28 boxes, including the roof modules. So it'll be about 8 boxes a floor. That allows us to be much more flexible in transportation. We no longer are reliant on wide load trucks or permits or, you know, all those kinds of things. But it also gives us a lot more design flexibility, because if you have more structural, you know, points where things are coming together, you just have a lot more choice in terms of what the spaces look like. So we are keenly aware of that. And then I said two things, but the last thing I'll say is we generally, even though right now we feel like we can get the most precision by delivering volumetric boxes, we're kind of agnostic about where the work happens. So the labor that people are doing is augmented with software that's helping expedite how things are built and giving people more information. That can happen on site too. So, you know, depending on workflows, we're not didactic that like it has to be in a box, you know, and it has to be in the factory. It's much more about the process and about where we are right now in our development, which is that right now the highest quality work can happen in the factory, but we don't have sort of like a break point, like it has to be this level of finish or not this level of finish in the factory. The goal is that it's one continuous build process, and the location doesn't matter for every single individual component.
Great. Thank you very much.
Thank you, Larry. And this has been wonderful. Thank you all so much for such great questions. Bev, do you have anything you'd like to say?
Yeah, I just want to say a big thank you. Reframe, amazing product. You don't get things that check all the boxes, and I think we are here. We just need to bring costs down and add more flexibility and scale, right? This is really exciting.
Great. We have a couple more questions. Are we still okay to keep you for a few more minutes? Okay, great, wonderful.
Yes, for sure.
Great. We have a couple more questions. If you have anything else to add, or if I've skipped you inadvertently, please add your question in the chat and I will make sure to ask. It looks like next up we have Scott Rodman, and it looks like he's still on the call. Scott, would you like to come off mute?
Hi, Kim. Thank you. Thanks for a great presentation. That's very exciting to see. It's absolutely what's necessary in this in many markets. A couple quick things. Some of them some related. I noticed the structure has no overhangs. I was curious about that. About when you talked about the modularity and the movement, the boxes. I presume that has something to do with it. But that sort of goes against some of the thoughts of you know, water management and so forth that Mr. Bazak has encouraged me to think about for quite a while now. And I also was asking about HERS ratings. I was fascinated to see what the HERS rating is, sort of pre-solar as well. And those are the first two. So thank you.
Yeah, I think I answered it on the chat, but I can bring it up quickly for everyone to hear. So HERS rating pre-solar was 37. HERS 37, that's where the pre-solar as designed was. And to answer your first question, I mean, honestly, our architecture team, we love overhangs. It was difficult to do this in this site. And also the design that we had for our overhang for Dorothy, we had a design with an overhang, but we had to scrap it because of how complex it was getting. And so at some point we were like, okay, like let's go with a very typical kind of like gutter system and not have an overhang. And it's a marginally slope roof, but in our building system, we are definitely considering overhangs and everything that you were talking about. It's a really good point. And yeah, it's for example, like for our triple decker project, we are thinking of how to best approach the overhang, especially how it interacts with the primary air barrier and how it goes back, like it structurally interacts with it, but also of course, like that's something that we will need to work as a prefabricated component separately, and it gets installed on the site, right? Because we have a restriction in terms of the white load. So those are the couple of things that we are very excited to finally solve for at a different scale. And yeah, we'll be excited to share that design very soon.
And I didn't see gutters on there either.
Yeah,
being added?
There is a gutter on the back side of the building towards where the slope is, which is on the other side of the building. And well, if you have not seen it in the photos, then maybe we did a good job in hiding it.
Great job.
Yeah, so yeah, we try to hide it with the aesthetics. Yeah.
Thank you very much.
Great, thank you, Scott. Next up, we have a question from Kyle. Let me see. Looks like he is gone. So just stop me if this has already been asked because I've been a little distracted. Question on the helical piles. Do you see that as a long-term maintenance risk? Also, did you create a chase for utilities? And lastly, is it accessible, or was that one of the trade-offs?
Yeah, I did answer it that, but real quick, it's we involved a geotech engineer to do an entire site review, and we are totally aware that not all sites will be compatible with purely helical piles, and so we are actively looking at what that means to our foundation system going forward, and maybe that's where like things like Sublime and others can come in, right? Where helical piles are not compatible. It's not truly an accessible space. It's an 8.5 inch above finished grade. In terms of maintenance, we used the Goliath Tech helical piles, and they get welded in, and you basically do not need to do anything else. It's basically a very secured system.
Perfect. Okay, next we have Paul Adams. It looks like he's still here. Paul, would you like to ask your question?
Yeah, I was asking about what format of software does he use, because the .ifc is the format we can exchange, with ArchiCAD and Revit and other major BIM programs. And so to have something off to the side, that's kind of where I've run into problems just using basic SIPs and other panelized systems, is just having enough flexibility with my own stuff, instead of being locked into some other system and then have to make my work kind of correspond to that to get it out the door. And usually that means the project doesn't go forward that way. It's just another stick house. So that fluid communication, so I can, as an architect, I can take what I work with, get it to you directly and not have to go through some other gyration. The passive house software already fails on that point for me, that you have this special software that you need skilled training just to operate. And now if I want to include that, there's a whole nother layer of complexity. And to get to the factory part, I don't want to have that sort of mediary between me and getting it done. So that's where I would hope that you could move forward with something that at least allows IFC or other easy sharing with the industry that's already here.
Yeah, that's a great question and a great point. And our digital automation team is really they hit a roadblock when we went all in with BIM, and it didn't work out for us because BIM was very BIM was working, Revit was working up until like the AEC stage, and then as soon as we hit the manufacturing side of things, because we have robots and digitization, it was like it didn't work for us. So we have made a bet that at least on the manufacturing side, we are moving away from Revit and focusing on this software called Onshape. It's basically coming out of SolidWorks. So all of our AEC stack sits in Revit/IFC, and we use IFC to exchange information between us and our external consultants like MEP, and other consultants. And then downstream, we are taking the IFC and moving to Onshape and doing all the work on the Onshape side. And that is something we still need to test on scale, but at least it is working at the stage that we are at right now.
Okay. Well, thank you for that. I appreciate it. And you're doing some amazing stuff. I'm really looking forward to seeing how this develops and where we can get some more of these microfactories going.
Awesome. Yeah, come visit us. We are right here.
All right.
Thank you so much, Paul. It looks like we're coming towards the end of questions. If you had another question, feel free to add it to chat. We'll be here for about 4 more minutes. Next up, we have Stephen Stewart. I don't think this has been answered yet. Would you like to come on?
Yes, thank you, Kim. First of all, I'm really impressed with the concept of the microfactory, something that I've looked at and tried to advance where I live as a real means to build affordable housing and to really do a workforce development program that is meaningful. But I noticed, and I might have looked at it wrong, it looked like you're using standard 16-inch on-center framing. And if so, I'm wondering if you have considered how advanced framing would impact the strength of the building, lowered carbon footprint, and the shippability of a box?
No, 100%. We are considering advanced framing for our larger projects. So for the triple decker project, we are definitely considering that. For the first one, there was definitely a skill gap when it comes to advanced framing, and we wanted some of our build team to also go to a couple of passive house training providers to learn certain skills of it, and they did. And now we are definitely a lot more skilled to do that, and we see a lot of benefits with advanced framing, especially even like thinking about lesser material, right? And especially, and that really is that switch at the triple decker scale is something that you will actually see as a benefit at that percentage. It was something that was to take for a smaller project like an ADU, and it didn't really give us any significant benefits in one ADU. But then that's something right now, as of today, we are a lot more well positioned with advanced framing. And yeah, we are actively considering that. With advanced framing also comes like a potential, like we have to do the math where can we go away from dimensional lumber to like replace some of the framing with engineered wood members, especially looking at the lower quality of dimensional lumber. So that's another forcing function that's making us think, if we go to advanced framing, can we then really switch the cost bucket to so like a less number of materials, but then switch some of the dimensional lumber with LVLs and see how the cost stacks up.
Okay, those are all really good thoughts and explorations. One final question, if I could. Do you have any idea what the percentage of the robotics adds to or detracts from the cost of what you're doing?
So we are tracking the cycle cost like really closely, but no, we do not have a really good cost number. I don't know, Jessica, if there's something you want to add to that, but as of today, we are actively trying to tackle the cycle cost, the cycle time and cycle time cost baseline. And we have a good understanding of that the 20 to 30% of the work that the robotic arm is doing right now, which is the framing, nailing, sheathing, is a huge time sink when it if there is because there's potentially a lot of rework that happens at those stages when done by humans, and we are actively trying to track that, but we don't have a quantified number yet. But would love to talk to you more about if you have any ideas of how we can track it better.
Yeah, I mean, I'll
Thank
just
you.
say that our reference point is to particularly in high cost markets to stay 20% below the market. We're pricing pretty far below that in Boston in particular right now. But yeah, but we have not looked at it from an individual component standpoint, although overall our goal is most definitely to get as much cost savings as possible out of the parts of the build process that are happening in automation and robotics, so that people are really focusing on doing their best work, and we're able to pay people well in the factory too.
Yeah, I will just add that there is a limit to the material cost reduction, right? And so we are really putting a lot of pressure on the labor cost and construction cost reduction. So at the large buckets of that labor cost piece lies in some of these larger components with like framing, nailing, sheathing, insulation, and which where we are betting currently that the cost reductions would come from.
All right, thank you so much.
Great,
Thank you. Thank you for the question. Yeah.
All right, folks, we need to let them get back to their days. Bev, any last words?
If you like this is recorded, pass it on. Thank you so much.
All right, thank you everyone.
So much. Yeah, thanks.